and we'll dive in. What do we got going on? Guess it would help if I was on the right browser over here. We are now talking today about working with built-in functions. So last time we met, we were, the whole idea was conditional branching. It was to look at how can we say, based on conditions in variables or the worksheet or the application or properties of objects, that we can say, as we're running this code, this part of code, skip that part and go to this over here. Conditional branching, only executing some of the code based on what other conditions that we found. And in so doing, we wrote a thing called a function procedure. Somebody remind me, what is the primary difference between a function procedure and a sub procedure? There's really only one difference. Okay, so maybe there's more than one difference. Yeah, so you can call both of them, but you can refer to like a function from within a cell. You can call it from different places. And the reason you can call it from in a cell is because after it's done doing its code, it does something different than a sub procedure does. Function procedure returns a value. It sends a value back to wherever it was called from. So what we're looking at today is we are looking at some built-in functions. So these are going to be functions that are just built in, part of the VBA language. And what makes a function is that it does something, but when it's done doing it, it returns a value back to where it was called from. So we have this workbook to download, transactions.xlsm. We'll go ahead and get that downloaded and ready to go. And it looks like I'm still showing the screen. Let me stop the video. And I think we're good now. And I have that up right here, actually. Close this. Okay, so one of the really common uses of a VBA is saying, listen, I've got some data that has come to me and it's not quite in the format that I want. Maybe it's not clean, maybe it just has fields joined together. And so we're going to look at, we're kind of getting down the road of parsing text. So the term parsing text just means I've got some text and I want to write a program, a little sub procedure to look at that and understand, based on the structure that text has, understand the meaning of it and extract different parts out of it. So we're talking about parsing text. So we've got this information here, and I'd like to say I've got a first name and a last name. I'd like to split these out into two separate columns. Now, we could do this pretty easily with text to columns, but I'm using this as an example to introduce us to some functions in VBA. So I'm going to open up my Visual Basic Editor. Bless you, my son or daughter, whoever comes. What do I have here? It looks like I've already started us off with a loop. And this loop looks like kind of our standard loop. It's just going to loop through this data as long as we have data. So I've got a sheet called transactions. And if I look at its code name, the code name for my transaction, so transactions in parentheses, that's what shows on the tab. TXN is the code name of that sheet. So I can refer to that directly by that worksheet, directly by its code name. Here, that's kind of nice, pre-named for me. And I'm going to do until whatever cell I'm referring to from the current row and column 1 is blank. So we're starting off at row 2. We're just printing off what's in column 2. And then we're going to increment this. We got a do loop. So this should just print off the names of the folks here, like the row number and the names of the folks. I'm just going to run that and make sure I've read that correctly. Yeah, so that's just going through all the data. So we got 278 different folks here. And so far, so good. Just a loop that does that for us. So now what I'd like to do is in here, before I increment the row, I'd like to start working on cutting this stuff apart. So let's go ahead and do the first name. So I'm going to parse the name here. Parse name. All right, so this is going to introduce us to a function called inString. So let's just take a look at inString. Maybe I'll just kind of wrap inString around one of these examples up here. So I'm going to print instr. So instr is the name of the function. It's short for inString. I'm trying to find the position of one string inside of another string. And the first argument that I put here is, where should I start looking? And I'm just going to put a 1 here. Start looking at the beginning. If I had a really long string, I might say, you know what? The first 5,000 characters of the string, I don't care about. Start looking at character number 5,000 and then move on from there. But in this case, I want to start looking at the beginning. The second argument is, what is the string that I'm looking at? And so I'm just going to kind of put this Caleb Crutchard's name as the string that I'm looking at. And the next argument is the string that I'm looking for. In this case, I'm going to be looking for comma and a space. Now, this is one of the things that has always struck me as deficient about text to columns, like the text to columns function. There is no way for me to split text on more than a single character. I can split text on multiple characters. I can say, hey, split this text on every comma, every space, every underscore, but I can't say split this text when you find a comma and a space like I'm doing here. What would I have to do? I'd have to do a find and replace the comma and the space with something else that I could look for if I was going to do this with text to columns. And then it's got some other arguments that are optional. I'm going to leave that one there for right now. And what this is going to do is it's going to show me the position at which it finds the comma. So it's a little bit confusing because I got quotes and commas going all over the place here. But here's the second argument, comma space. And it's going to tell me where it finds comma space in this string. And it will tell me it finds it at the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th. It finds that at the 10th character. So when I say, hey, print out the in string, starting at the first character, looking at this string for a comma space, it'll say, I found that at the 10th character. I could look for something different. It doesn't have to be a comma. I could look for like capital C. And capital C. And that's going to find it where? What should that return? What should this print? Yeah, that's the very first character. Finds it at the first character. Unless I tell it, don't start looking at 1, start looking at the second character. Now it's going to find capital C way out here at the 12th character. So I told it to skip the first character, start looking at the second character, and now it's going to find it way over here. Now, that brings us to this next argument, which is, what's the compare method that I want? Compare binary is the default. Compare binary, it's actually looking at the underlying ASCII code behind the character. So a capital C is an ASCII character of 65, 66, 67, of 67. Lowercase c is a underlying character of something higher in the 90s or low 100s. But I can also say, do a text compare. If I make this a text compare here, this last argument, then it will say, you know what, ignore case. So now I told it to find capital C, but to ignore case, and so where does it find it? It finds it as the 5th character right here. So that's handy. I can either use it as a binary, which is the default, which matches case, or I can say ignore case in this search. There's another one in there called database compare, and I think what that means is use whatever comparison is currently configured, because it's a common thing in a database management system to say either string or case matters in string comparisons or it doesn't matter in string comparisons. And I think depending on how Windows is configured, that maybe actually look at how Microsoft SQL Server, like the main database management system for Microsoft, they'll just kind of mimic that. I've never used that in Excel. So text compare is the one you would say ignore case, or the default is to make case important. Now, the interesting thing is that this doesn't just tell me that it's in there, it tells me where it finds it. And so I'm going to want to know where did it find it. So let me declare a variable up here at the top. I'm going to dim something to keep track of the position where it finds the one string inside the other. So I'll just call it POS as an integer. POS is short for position. Don't get any other ideas about what that might stand for. Plan of salvation or plan of salvation. So now I'm just going to set that equal to, so POS equals, and then I'll do the in-string function again, instr. Now, I'm start at the first character. And I'm trying to figure out how to split this into a first and last name. So I want to know where that comma is. So I'm going to say I'm looking at the current row in column 2, and I'm looking for comma space. And let me go ahead and just run a stop to right there, stop, and I'll run this code right to there. But now I should be able to come and take a look and see what my position is. It says it's the 8th character. Does that make sense? Brandon. And put it here. So there's the first character, 2, 3, 4, 5, 6, 7, 8. Yeah, so I found it at the 8th character. So far, so good. Okay, so that's in string. In string's really handy. Lets you look to see where one string occurs inside of another string. So now what I'd like to do is I would like to use that information to take just the first name, to extract just the first name off. And I'm going to put that into column C. So let me just go ahead and after I've done that, I'm going to say column C, and I can put a 3 there, or I can put a C. I'll just go ahead and put a C. So column C of my current row now is going to equal, and I want just everything that comes up to, but not including that space or that comma. Unfortunately, there's a function that does that. It's called left. So left is a string function, and it allows me to take a certain number of characters off the left of some string. So the string that I'm interested in is, it's whatever's in column 2 of my current row. And you know what? I think this is going to make the code a little bit easier to work with. Let me just make a variable here that I'll use in several of these examples called temp. So dim temp as a string. And then instead of doing this, like before I do the POS, I'm just going to say temp is equal to, and I'll read off the worksheet here just once. Because that's kind of, there's a lot to kind of look at there and understand. So let me just kind of get that out of the way. And then I'm going to look at temp. So instead of looking directly at the worksheet and seeing what's the value of column 2, I'm going to start off by reading that into temp, and then I'm using temp to find out where the space is. The same thing. Like I take that value, put it in memory at a location, and then look at that memory location. But now it's just going to make this left part a little simpler, because now I'll look at temp, which is holding the full name, and I'll tell it how many characters do I want. How many do I want? Position, is that what I want? Let me count again. 1, 2, 3, 4, 5, 6, 7, 8. If I ask for the 8 most left characters, I'm going to pick up that comma. And so instead, I'm going to ask for that position minus 1, 1 less than the position. So the position actually is where the comma is, and I want to stop before that comma. So now I'm going to just stop my code and run it again. And we can see that we've put Brandon in there, and yeah, there's no comma after it. If I kind of double click on it, I can see that there's no space at the end either. Zoom in. There we go. Okay, so now I'd like to get the last name. So that's in column D. There's a couple of ways I can do this one. There's a left, so there's probably also a right. Yeah, let's do this with right, and then we'll do it a way that's a little bit simpler. So the right of temp, how many do I want? How many characters do I want from the right? Well, the guy's name is Chilton, Chilton. So I want 7. But I somehow have to figure out 7 based on looking at that string. Any thoughts? Yep.
Somehow use the line, well, we figured out everything to the left, and then say like add 2 to get past the comma and the space, and then look at everything on the right.
Interesting. So what you're saying is what Well, we know based on the position, we know how long that is because how long this took off was a function of the position. So we can use the position, but what other information do we need to know with the position to know how many to take off the right? The length, yeah, the whole length of the string. Because if I take the length minus the position, that's going to get me pretty close. So let me just kind of do it here. Here's Brandon. And there's a function called len, L-E-N, which returns the length of the string that I'm looking at. So there's the overall length is 16. So if I take the length minus my position, and I can access this position right now because I'm in break mode, right? I've run this, position is assigned, it's got a value, and then that will give me 8. And what am I looking for? How many do I want off the right? 6, 7. So it looks like I just need to adjust that just by subtracting one more off of that. And that would give me how many characters I want off the right. So now I could say, look at the right of some string and that many characters off the right. And what's the string I'm looking at? Brandon. And this should give me just Chilton. So that would be one way to do it. So I want the right of temp. How many do I want? I want the length of temp minus position minus 1. And that should put the last name into that column D cell. Ugh. That's more work than I want to do. But at this point, it's a sunk cost. I've already done it. Maybe I should just move on. But the real work of the day is teaching you some different functions. So let's look at a different way to do this one. So instead of this, maybe I'll just copy this line because it's going to start the same. And instead of the right, I'm going to use one called the mid. So the mid takes a string out of the middle of something else. I'll adjust this one up here. I want the mid of this one. And I'll tell it to start at, let me just kind of do it this way. I'm going to start at the third character, and I'm going to take 4 characters. And that is going to say, oh, your third character is A. 1, 2, 3. Yeah, I'm starting at the third character, and I'm bringing back 4. 1, 2, 3, 4. That's why it did that. Now, if I don't tell it how many to bring back, it brings back the whole rest of the string. So I can tell it to start at position, and it will bring back comma space Chilton. So position plus what? Yeah, position plus 2 will bring back just what I'm after. So instead of this length here, I'll just put here position plus 2 because mid looks at from the middle, and if I don't tell it how many to take, it takes everything to the end of the string. So if I were to delete Chilton, and go back and run that line again. Oh, I got minus 2. It should be plus 2. Mission accomplished. So that's left, right, and mid, and that's the bread and butter of parsing strings. Like those are the functions you will use over and over and over again, trying to adjust those, like pull information off of another string. Questions here? And I'm not looking, so I'll call out if you have a question. All right, so what's our next one here? Phone number. I think what I'd like to do here is I would like to convert this phone number from one format to another format. And I'm curious, does that have a space on the beginning, or is it? Yeah, it looks like it's got space on the beginning I'll have to deal with, and it's got a space on the end. And from our little thing that we learned last time, space may not always be a space, right? It could be a non-breaking space. And I'm not sure what we're dealing with here. So let's just try to, I'm going to start off by referring to, I'm going to write to column F. And I'm just going to read off of column E. Well, let me go ahead and I'm done working with my name. So I'm going to write temp is going to be whatever is in column E. So I'm reading in the phone number here. In fact, maybe I'll put here phone number. So temp should have just exactly what's in the cell. Now I'm going to write to F. So my first step is going to be, I really can't tell just by looking if those are non-breaking spaces or if they're real spaces. And so I'm just going to trim. So trim of temp should, if those are spaces, it should just erase the spaces. Take the leading and trailing spaces off. So I'm going to come back up here and run from temp to pick up the new value for temp, and I'll run that and see what we get. Yeah, it looks like those were just ordinary spaces because now they're gone. But I'm only partway through with what I'd like to do with this phone number because I want to convert this from this format of the phone number that has hyphens between the area code and the other one to putting parentheses around the area code and then putting the rest of this, kind of another standard way to look at a US telephone number. And so here's what I think I'm going to do. On this one, I'm going to start off by trimming it. So instead of just writing the temp into here, let me say temp equals that. And then I'm going to change what's in temp. Temp is going to equal now the trimmed version of itself. So I'm saying, hey, let's write a value into temp from the worksheet. And then let's look at temp and trim off the leading and trailing spaces and put it right back into temp. And now I'm interested in figuring out whatever comes before the hyphen. Now, the fact that I've got two hyphens, I could use in string here and find the first hyphen and then go find the second hyphen. But it turns out there's another built-in function that is used for splitting apart a string based on a common delimiter. And so in this case, where I've got really three parts of the string that I want to have access to, and we've got that delimiter in there, I'm going to use this one called split. Yeah, and split's a little bit complicated. So let's just take a look at it. I'm going to come in here and I'm just going to I'm going to start off by putting in just the area code. So I'm going to say the split function. And what am I going to split? I'm looking at temp, which should be my area code with, or it should be my telephone number with no spaces, front or back. And then I'm going to tell it what character to use to split the string. And it's a hyphen. So this should take that one string and return 3 strings. Now, as it turns out, a function is not allowed to return 3 values. A function can only return 1 value. And that's the definition of a function. But in the world of VBA, we can have it return a data type that is a complex data type. So it's going to return one thing, and that thing could have multiple things in it. And the thing it's going to return is called an array. We have 2 days, 2 full days to talk about what an array is. And so I'm not really going to explain all this to you, but I'm going to show you how to use it at this moment. So this right here is going to return a complex structure called an array. And I can tell it, and it really be a structure that has those 3 parts built into it. But I'm going to tell it which one I want just by putting another set of parentheses. And I'll tell it, I want the number 1 position of that array. So this statement here says, split it into 3 strings based on the hyphen and bring back the number 1 item. So I'll run that now. Let's see, did I already run the one to trim it? I'm going to go ahead and come right back up to where I pick up temp in the first place here, because I just don't remember if I've run this intermediate one yet. And I'll run that. And now it's put 206 as in phone number. Is that right? Hey, wait a minute. What's wrong with that? Yeah, it's not the area code, that's the prefix. Well, it turns out that arrays, like when you're trying to refer to an element in an array, they start counting at 0. There's a good reason for that. It's a confusing reason. We're not going to talk about it today. We will talk about it when we talk about arrays. But arrays, when you're saying, hey, I've got an array here, I want one of the elements from the array, they start counting at 0. And so that now should bring back the area code. I run that one. So I got the 520 there. But what I'd like to do is I want to put that in parentheses. So I'm going to concatenate on a string, literal. And what's going to be in the parentheses, just or what's going to be in the quotes, just an opening parenthesis. Then after it, I'm going to concatenate on closing parenthesis and a space. If I run that one now, I should get the area code inside of parentheses. Did I not run that? Ah. Okay, let me back up here. I'm going to run this. And that should give me just the area code 520. Oh. Does anyone know what happened? That was weird. Let me back up. I'm going to run that, and suddenly, oh, I got to the next row. Whoops. Now this is negative. I'm on this one now. It's negative 202 or minus 2. Why did it? How did the hyphen even come back here? I thought I got rid of those when I did the split. Yep. That is a good hypothesis. It is incorrect. Let me just add in, I'm just going to add in here 45. My accounting student should know the answer. Yeah. Yeah, in the world of accountancy, parentheses means negative. By the way, why do parentheses mean negative in the world of accounting? Do you know the answer to this? There's a real reason for this. When was debit credit accounting invented? Not BC. He codified it, but it's not that much older than him. Debit credit accounting comes into existence because we need to be able to have more precise accounting to be able to do a joint venture, to be able to say we have like multiple people investing in this really risky thing. And if this thing pays off, we're going to have to know how much of the profit goes to each one of these folks. We needed more precise accounting, and that's what debit credit accounting was invented for. When did we start getting these joint ventures? 14th century. So 1300s is when we start getting, we're saying we're going to build a ship. We're going to send this ship down the coast of Africa. We are going to trade beads for whatever they have in Africa. It's not slaves for another 100 or 200 years. And, you know, these folks love glass beads, and we can make them real cheap here in Europe. And so it's going to be a really favorable thing of trade. And so that's great. You know, we're going to make a lot of money on this if the ship comes back. If the ship doesn't come back, you all lose your, but if it does come back, we got to know. That's when it gets invented. When do we get, like when does the idea of a negative number even come into play in Western civilization? I don't know, but it's after this. And so parentheses are a way for saying, somehow this number is different, and we're not even really quite sure how to deal with it yet. And is that the reason that we have parentheses? I'm really not sure, but that was kind of an interesting story. So yeah, the problem is that when I put parentheses around that, it thinks it's a negative number. So we're going to live with that for now, because we're about to do a little more that's going to make it not into a negative number. All right. So that's the prefix with a space, with parentheses and a space. Now I'm going to concatenate onto that the next part of my example. So I'm going to split temp again. And this time I'm going to bring back the number 1 character. And now I'm going to concatenate on a hyphen, and I will concatenate on the 3rd character, the number 2 character. So in this case, I'm actually splitting it 3 times. I'm splitting it once, taking the first, splitting it once, taking the number 0 element, and splitting it again, taking the number 1 element, splitting it again, taking the number 2 element. Boy, that's a lot of stuff in there. And I'm going to stop my code and run it again so I get back to my first line. And now it has formatted that phone number. Okay, so now those parentheses stay here because it's looking at what the whole thing I entered in. It's going, that's not a negative number. I don't know what it is, but I'm just going to display what you put. So there we go. It turns out we could split that into another variable and not have to actually call the split multiple times. Do you want to see that? Let's just do it. So in this case, I'll call it phone. Dim phone as variant. Like the first time I've declared a variant variable in class. Remember, variant is that type that just can behave in lots of different ways. There's a little bit of overhead involved with using it. 22 bytes of overhead to be precise. So now I'm going to say here's temp, and I'm going to say phone equals temp, split temp on the hyphen. So now everywhere I have split temp, I've actually held the results of this split temp into this variable called phone. So everywhere I have split temp, I can now just refer to it as phone. That'll simplify this code substantially. So now I'm only splitting it once. I'm capturing that array. I'm capturing that complex structure that comes back from the split function, and now saying, just give me the first, second, and third element off of that. I'm going to run this up to where I catch the phone, and I'll delete this off. Run it again, and that should put that same thing in. Question? So the question is, why did we have to make phone a variant? And so, what are my options? Can I make it a string? No, I can't make it a string because it's not bringing back a string. It's bringing back a complex structure that has 3 strings built into it. I can't make it an integer. I can't make it a byte. I can't make none of the other types that I know will work. Variant is the one that will just do anything. That's the reason. Yep.
If you don't put eyes as variant, does it just default to a variant?
Yeah, so if I didn't put as variant, it would actually be a variant. And in fact, if I didn't have option explicit up here, I could skip the dim part altogether and just say phone equals split this. And the VBA interpreter is going to get to this thing phone. It's going to say, I have no idea what that is. It's not a worksheet. It's not an object. It's not a built-in function. It's not a variable. Like the only thing that he could possibly mean, the only thing my programmer could possibly mean is a variable. He didn't declare it. So I'll declare it. Like the interpreter would like automatically allocate memory for it. And because it didn't tell me the type, it would be a variant as well. But it's, yeah, you might think, hey, that's less typing. That's a really bad idea. Because this is going to protect me against misspelling a variable name. Because if I have option explicit on up here, and I type a variable name backwards, it'll tell me, hey, that's a mistake. So you really want to have option explicit on and declare your variables. Because a misspelled variable name is one of the hardest errors to find. Okay, so I think we got phone 2. Moving on. Okay, so let's come over here to address. And we got to get the street address. So I think I'm liking split for this as well. Split doesn't quite do everything for me because I've got 2 parts here that I've got to split up that aren't done, but let's go ahead and let's do what we can with the split. All right, so here's our phone number. Here's our address. And in fact, I think on this one, I'm just going to split it. I'm going to split it right off of no, I'll go ahead and bring it into temp. So temp equals whatever's in column F. And now I'm going to write to column EFG. And I'm just going to split temp. And return the 0th character. Oh, shoot. Apparently I meant to read that off of column G and write it to column H. Well, apparently Erica, oh no, yeah. Oh, Brandon's the last name. Apparently Chilton and Enrica just got married because they now have the same address. All right. So now I'm reading out of G, writing to H. City should be really similar. I'm just looking for the next element. So HI is going to be temp 1, split temp 1. Looks like that's gotten me the, oh, yeah, whoops. What's my problem with the way I've done split here? Yeah, I didn't tell it to delimiter. Instead, I put the, like the index that I want where the delimiter goes. What's my delimiter here? Comma space. And I want the 0th position. And here I want the first position. I'm going to stop and run back up here to the first one. I've stopped my code and running it again from scratch, so it should get me the first city and state plugged in there. Street address and city. And now I'm done with needing the street address and the city. I just now have to wrestle with the state. So why don't we go ahead and pull set my temp equal to just what's in that third position based on the comma space split. So now temp is going to equal split temp, but bring back the number 2 element. And so at this point, I'm going to go ahead and run that line, but at this point, temp should be holding the state and the space. I'm sorry, the state, the space, and the zip code. So there it's got Ohio 45020. Okay, I got to now get after these two. What shall I do? What's that? Okay, split at the space was like when I first tackled this, that was my first approach. This is simple. Split on a space. That doesn't work. Why not? It will work for this one, but what won't it work for? Just look at some of the other data that's visible on the page. What is it? Yes, space is a valid character in a state name. And so I don't want to end up with, that would have 3 spaces instead of just 2. So let's do this one. So this will introduce us to another one. What I really want to split it on is I want to split it wherever the last space is. And so I'm going to do this. I'm going to come down here to set my position variable. I haven't used that for a while. It's just fine. I'll use it again. Equal to INSTR in string EV reverse. It's like the reverse. It's in string happening in reverse. Now maybe it has 2 R's. Yeah, it's INSTR REV. So now this one doesn't give me a position to start at. I'm starting at the end. Now the string that I'm looking for is temp. The string that's the string I'm looking in. The string I'm looking for is a space. And it doesn't matter if I match this with exact match or a case insensitive match, because the uppercase space is exactly the same as the lowercase space, right? Those are the same. So I'll go ahead and just leave that way. So now that should show me the position of the last space. What is POS? It's 5. And for Ohio, now it's not showing me how many characters it is from the end. It's showing me where the space is from the beginning, but it found it by looking from the end. And so, is that right? 1, 2, 3, 4, 5. Yeah, it's the 5th character. So now I just want to take everything after that. So let me go ahead and write into column J. Is going to be the mid of, well, no, this is the state. This is going to be the left of temp. How many characters do I want? Position -1. So that's J. And then K will be the zip code. And that will be the mid of temp starting at the position +1. It's just one space I'm looking for. I think that will do it. So that should give me the state and the postal code. And again, I don't remember how much of this I've run, so I'm going to stop it and run it again. Okay. Boy, I think at this point, I'm ready to kind of fill this data in. So I'm going to just comment out my stop and run it the rest of the way. That looks pretty good. I've got city, state, and zip, but some of my zips look wrong. Can anyone see the problem? Yeah, if I look at the zip code here, what do you mean, does it start at 0? So instring doesn't have the same 0, 1 question. So when I say start at 1, it means the first character. But what's wrong with the address over here for Newton, Massachusetts? What's wrong with the zip code? Oh, maybe it's a format issue. It's not a formatting issue, but it is have to do with starting with a 0. What happens? Yeah, why does Excel cut off that leading 0?
The number is just like, well, why not put 0 for space time?
That may be exactly what's happening inside that measly little brain that Excel has. Yeah, but it's actually more complicated than that. Like even if Excel wanted to put the 0 there, it couldn't put the 0 there. And here's the reason. It's because it's storing it as a number. It's actually storing the underlying numeric value, right? So if I had open, let me just open up like Notepad here for a second. So what Excel is not doing, and what was it? I forgot the zip code. We're looking at 02458. Okay, so that's the zip code. Tiny little zip code. Okay, Excel is storing, it's not storing the 5 characters. It is storing, it's the number. It's storing, like in memory, down in a bunch of, I don't even know what they are. Like on a magnetic disk, they're positive and negative charges. On a optical disk, they're little divots or the absence of a divot. I don't know what it's actually storing it in as in a memory chip, but let's think of it as 1s and 0s. It's storing 1s and 0s for this value. What is the difference in 1s and 0s between that value and this value? Do those two numbers have a different binary representation? They have exactly the same binary representation. So Excel is storing the binary representation. It can't possibly know to put a 0 on the front of it. Unless you want a 0 in front of all of your numbers, maybe you could do that. So we put in this character that starts with a 0 and Excel goes, yeah, that's a number. I know a number. Leading zeros don't mean anything. It stores it as a number. So if we want to keep that 0 around, we have a couple of options. What are they? let's try that. So let's take this and let's just C string. CSTR, CSTR. There's convert to a string. And I'm going to clear these out just so you see that it does something. And I'm going to run the whole thing again. Good news, we converted it to a string, and Excel did exactly the same thing. The truth is, it was a string before. The mid function returns a string. And so when we put a string into a cell, Excel is going to look at that and say, you put a string in here, but that's a number. And it converts it. So what else can we do? Yep. Excellent. Okay. So you recorded yourself doing it. I'm just going to do it actually right here in the worksheet. So I'm just going to take this column and I'm just going to format this as text. Boop. Did you see those numbers all shift over? Because text gets recorded at the left-hand side of the column instead of the right. I'll run this again. And now that that's text, when I put in that 0, it's going to be like, oh yeah, I'm text. I'm okay with that. Let me show you the other option. Oh, and the option that you suggested, record it and like change the format of the cell. That would work as well. There's one more kind of simpler thing, a little shortcut. I'm going to put this back to general. And run it again. Hopefully those go back. Yeah, it's like still stored these as text. That's so interesting. I think this will get us back to normal. No, it's still thinking those are text. Did I not have the whole column selected when I said text? Curses. Okay, so now we're back to the same problem where we lose that leading 0. So our other approach is, and this can be a handy little trick, is that when you plug into a cell, if you say, you know what, I know I'm putting a number in here, but I want you to treat it as text, get off my little C string here. If I prefix this with a single quote, and that's kind of ugly, but that's a double quote. That's 2 double quotes with a single quote in the middle of it. So it's quote, string, single quote inside the string, and then a quote to terminate the string. When I do that, it says, yeah, you know what? Just treat those as numbers. I mean, treat those as text, even though it's still formatted general. And when I look at the cell up here, I can see that single quote, but look what I don't see if I was just to ask for the value of that cell. So that's now my active cell. Scroll over to one. So my active cell is the one with that 0, and you can see the single quote inside the formula bar. But if I just say, show me the value of that, I'm not sure what I just did. I hit an errant key and everything is. If I just say show the value of that, it will show just the characters without the single quote in front of it. So active cell. Dot value. So even though I put the single quote when I was setting the value of that cell, and even though that single quote appears in the formula when I look at it, if I ask for the value, it knows that single quote is not part of the value. That's just, it's like a shortcut notation saying, treat this as text, even though it's in a cell that's not formatted as text. So those are all possibilities. All right. Oh, and it looks like my intention in this example was to let the postal code go bad and then do the full postal code this way. No problem. So K is just not going to have the leading space on it. And then HIJKL is going to get the one with the full postal code. So now we've got the postal code that has been lost its leading zeros, and we've got the postal code that maintains the leading zeros. Ooh. Show me your comfort level with what we've done today, 0 to 5. 5, 5, 5, 5, 5, 5, 5. Excellent. Oh, what else we got going on here? Emails. In this case, looks like we've got a couple of leading spaces here. And this is actually another example of those. Go ahead and do email here. You remember that we talked about those non-breaking spaces. They were the bane of my existence until I really understood that what was going on. Because whenever I copy your emails off of like the class list that shows up in AIM, like in our system, they have these non-breaking spaces, both in front and in back. So let's just go ahead and get rid of those non-breaking spaces. So probably the easiest way to do this one, email, is just to say that column LM, this is column N that we're after. Column N equals, let's go ahead and kind of do the same pattern. Temp equals the value from column M. And then we're going to write to column N. And we're going to we'll just use replace. So here's another function we haven't seen yet. So replace says, let's look at a string that we want to replace the values in, temp. Let's try to find some particular characters. I want character number 160. That's that non-breaking space. And I want to replace it with a 0-length string. And that will replace every occurrence of the string I specify here. It could be more than one character with the string I specify here. This is going to take out every non-breaking space in that string. Now, when you say replace, it almost sounds like it should be changing what's in temp, but this doesn't. This is a function. I send temp into it and these other values, and it sends back a version of whatever I sent in that has those characters removed from it. So if those are both non-breaking spaces, in fact, let's just go ahead and I'm going to kind of show you how you can tell. So what I want to see is the ASCII value of the mid of my active cell, starting at the first character, taking one character. So remember, ASC is the function that says, look at a character and give me the ASCII number of it. That's either going to be 32 regular space or 160 non-breaking space. That's 160. So I'm looking at the mid of my active cell's value. I didn't say dot value, but it assumed that's what I meant. Starting with the first character taking one, now let me start the second character taking one, and that's 160. So these are both non-breaking spaces. If I was to come in here and put another space in front of my active cell, like just a regular space there, then my third character should be character number 32. Oh, thank you. Well, I was on active cell, but it was a different active cell. So 32 is the normal space. So this should say, hey, look at whatever's in temp, and I read temp out of column M. Look for every occurrence of character number 160 and replace it with a 0-length string. That's how we say to get rid of it. And so now if I run this, then we no longer have those spaces on the beginning. This one has the single space that I put in front of it, so I'll get rid of it. So I should get rid of it over here. So replace is a really handy one. And we have some other flexibility with replace. We don't have to look at the whole string. We can tell it where to start looking, start at here. We can tell it how many to find, like only replace the first 3 that you find after where you started looking. And we can tell it to do a binary comparison or a text comparison. So we can say case matters, case doesn't matter, start at a particular place, stop after you've replaced so many of them. So replace is really kind of handy. I almost never do anything except replace every occurrence of this string with something else. But you got that other flexibility. Questions? So that's replace. Gender. When do I have gender here? I don't know. Okay, so now we're getting to some other data here. Make, model, VIN. Oh boy. We got credit card numbers. This is awesome. We should like go see if these work still. Let's look at the VIN here. Anyone ever like work in the auto industry? Like, what can you tell me about a VIN? Ah, so you can look at this. If you know what you're doing with this VIN, you can look at this and tell where it was manufactured. Can you tell like the make and the model by looking at the VIN? Yeah. You can even tell the year it was manufactured by looking at the VIN. Sort of. In fact, I think if we look over here at my little sheet called WMI, so WMI, I don't forget what WMI is. If only we had some connection to a worldwide network of information. We just look up the VIN on Wikipedia for just a moment. VIN wiki? No. Erg. The first three characters uniquely identify the manufacturer of the vehicle using the World Manufacturer Identifier code. So the first three characters will tell us who the manufacturer is. And what are these? Countries of origin. First character WMI is the region where it was located. Okay, so if we look over here, it's the first characters. If we look over here, we've got like a list of WMIs. So WMI VF5 is in France, and that's the manufacturer. Let's look at TSM, made in Hungary by Suzuki. Made in Slovakia by Kia. I thought Kia was like a Korean make. What's the Slovakia involved here? Apparently, Kia has a plant in Slovakia, or at least one time did, because like the whole structure of a VIN is able to say, oh, like this is a Kia car made in Slovakia. So what I'd like to do is I would like to fill in these other columns, oops, on my transactions. I would like to come in, plug the WMI here, and I'd like to get like the manufacturer. And this is already built into it, right? This says, hey, listen, if V2 is blank, make this blank. Otherwise, do the lookup. So as soon as I put a WMI in here, and that would be the first three letters, WAU, I should get the manufacturer. Yeah, so that comes in. Now, the other part here is the year digit. So what's the year digit? Ah, here it is. So I think it's the 10th character. Memory strikes. Yeah, the 10th digit is the year digit. So if the 10th character is an A, it was made in 1980. If it's a B, it was made in 1991. And you have all these digits here up until A through X, Y, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, oh, it starts again. So if it's a code of A, what does it mean? Yeah, this car was either made in 1980 or was made in 2010. And if you can't tell by looking at the car, you're in trouble. That's the idea. We're saying we're not giving you 2 digits to figure out the year. We're going to give you 1 digit. And then based on that, after that, you're on your own. So I think we're assuming these are all prior to 2010 just because I made this example before 2010. So in-class exercise, what I would like you to do is modify the code to put the WMI and the year digit, and that should put the manufacturer, the country it was made, and the model year, and that'll be the end of the example. So let's take 5 minutes until I'll set a little 5-minute timer, and just do it. Modify your code so it fills out the rest of this table. And again, the last 3 columns are already have formulas in them that will do it for you. Anything you want me to put on the screen while you're working on this? I guess I'll leave the year code up. If you have a question before we get to 5 minutes, let me know. If you get it done before we get to 5 minutes, look at me with a really smug look on your face. Is that you doing smug? That's pretty smug. You got it already? Yeah, looks like it. Anyone still working on it? About a minute to go. Western civilization does not get the negative number until the middle 16th century. So like the full debit credit accounting has been running for like 200 years before the idea of a negative number ever strikes us. All right. Six seconds to go. Probably started 6 seconds late anyway. Okay. Leave that. All right, so let's take a look at what we're going to do for the WMI. So WMI comes out of column R and it's the first 3 digits. So we should just be able to say temp equals column R And then we're writing into column V. Column V's value is equal to the left of temp, 3 characters. Year should be a mid. So temp is still the VIN, so we don't have to change that. But now we're writing to column QRSTUVW is going to be the mid of temp, starting at the 10th character and taking 1 character. It looks like we've got a bunch of data in here, and the rest of the table fills out. Made in Japan by Mazda, year 2011. Okay. Whew. I think that's it. Any questions? I think our book talks not only about string functions, like in the reading that was for today, also like there's lots of mathematical functions, square root and cosine, sine, tangent. So like engineering folks, you've got a bunch of mathematical functions that will be helpful to you. And there's lots of other string functions as well. But these are like the main ones that I use in the work that I do. And all the rest of the string functions, it's the same pattern. Like the function does something, you give it a string and some other parameters, and it gives you something back. Any questions? All right, let's call that good for today. Thanks for coming. Class dismissed. You're too kind. You're too kind.